To find the limit of a complex fraction, we've got some work to do. We can't simply plug in 0 for x, or we'll end up with 0 divided by 0, the indeterminate form. Let's simplify this complex fraction, multiplying everything, top, bottom, left, right, by every unique factor from every denominator. Notice that we've got some distributing to do. Top left, top right, and even the bottom. Now I've got some writing to do. That is, the limit as x approaches 0 of x plus 12 and 12 times the first term, room for the Holy Ghost, x plus 12 and 12 times the second term, and we'll do the same to the bottom. X and 12 times x. Let's see what we can cancel. Let these x plus 12s go. Let these 12s go. Nothing to cancel in the bottom. Let's see how it looks when we clean it up. Okay, that's how it looks. So, we could simplify. That 12 times 1 is just 12. I like to put my monomial at the front and show distributing the negative. That's the limit as x approaches 0. 12 minus x minus 12. Lots of stuff still in the bottom. We're wanting to simplify. These 12s are opposites. They can go. Who remains? Okay. Look at those x's. We can cancel them. The top is written. The bottom is written. There's only multiplication. What remains? The limit as x approaches 0 of a negative 1 divided by lots of stuff. Now that negative can be top side or distributed to the bottom. I've got no more simplifying. Let's go ahead and toss in that 0. It's negative 1 divided by 0 and 12 times 12, which is negative 1 divided by 12 times 12. And the limit as x approaches 0 of that complex fraction turns out to be negative 1 divided by 144. All right, away.